Welcome to Core Academy. I am Ashish. Today we will discuss Bayes' theorem part 1. Already I have made video on conditional probability. You first view the conditional probability, then you will be able to understand Bayes' theorem. But before studying Bayes' theorem, we must know the total probability, otherwise it is very difficult to understand Bayes' theorem. তো আমি তোমাদের এমনভাবে বোঝাবো যে তোমাদের Bayes' theorem কোনো প্রবলেম না হয়। তো ফার্স্ট অফ অল you must know the basic idea about conditional probability. যারা দেখোনি, যারা জানো না তারা conditional probability উপর আমার ভিডিও দেখো, then your knowledge on conditional probability will be clear. আমি তাও I am giving you a little bit idea about conditional probability. Suppose there are two event A and event B. What is the probability of event A when event B has occurred? Additional information, B event has occurred. This is equal to n probability of A intersection B, and denominator is nb, or we can write probability of A intersection B by probability of B. Numerator always not probability of total, numerator will restrict the numerator. The event which has already occurred, we take its probability, or here we take the number of B. We restrict the domain. We restrict the sample space, reduce the sample space which is already occurred. So I can write from here probability of A intersection B equal to probability of B into probability of A when B has occurred. These two relation is very important. You note, I am writing here in short probability of A when B has occurred equal to probability of A intersection B divided by probability of B, or probability of A intersection B equal to this probability of B. Probability of A intersection B is equal to probability of A when B has occurred into probability of D. These two result is very useful for understanding total probability and Bayes' theorem, probability as per Bayes' theorem as well. So let us start. Let us take an example, and with the help of example we will try to understand what is total probability and what is Bayes' theorem. What is the probability as per Bayes' theorem? You try to understand this problem. In a factory there are three machines. Machine 1 produces 60% of the output, machine 2 produces 30%, and machine M3 produce 10%. Total 100%. So defective percent are from machine 1 10%, machine 2 5%, and machine 3 2%. These are the defective percent. Find the probability of defective output. What is the probability of defective output when a product is selected at random? A product is taken out at random. What is the probability that it is defective? This is the total probability. What is the probability? Defective may be from any machine, machine 1, machine 2 and machine 3. So if an item is selected at random, what is the probability that the item is defective? So you try to understand this problem. Now let us take defective event. Defective के আমি ধরে নিচ্ছি D event. D stands for event that taken output is defective. So D is defective event that it is defective. So D is defective. Then you make this chart for it will be very clear বোঝার জন্য. Suppose three machine 1, machine 2, machine 3. What is the probability of selecting machine 1? Total output a random one item is selected. What is the probability that it is from machine 1? Machine 1 produce 60%. So the probability that it is from machine 1 is 0.6. 60 by 100, 0.6. The probability of M1 that which is from machine 1 is 0.6. It is the probability of second machine is probability of M2 0.3, 30%, and probability it is from machine 3 is 10%, that is 0.1. You see total is 1. Sum total of this side is 1. It is, you note it. যে কোনো প্রবলেমে এই দিকটা 1ই হবে, তো you add is 1. Now the defective, if it is from machine 1, the percentage of defective is 10%. So I can write it is a probability of defective when machine 1 is taken, when machine 1 M1 has occurred. This is conditional probability. The probability of defective when machine 1 is taken, that is probability of D by given M1. So this is 10%, that is probability of defective when machine 1 is selected. So this is 0.1, 10%. Now I can say what is the probability of it is not defective if it is taken from machine 1. So probability of D prime or D dash by machine 1 is 1 minus 0.1, that is 0.9. But I have, for your understanding, I have written this. These are not relevant for our calculation, because what is the probability of defective is asked. It is not asked what is the probability of not defective. Probability of not defective. So for your understanding, I have drawn the probability of defective when machine 1 is taken is 0.9, and probability that it is not defective when machine 1 is taken is 1 minus 0.1, 0.9. But for this problem, this part is not necessary. So I am erasing this part. এটা আমাদের দরকার নেই. আমার দরকার হচ্ছে machine 1 নেওয়া হয়েছে এবং তার defective probability কত? Probability of defective when machine 1 is taken is 0.1. Now if second machine is taken, the probability of second machine is 3. And what is the probability that it is defective, an item is defective when machine 2 is selected? It is 5%, so 0.5. So other portion is 0.95 is probability of not defective when machine 2 is not selected. So it is not our relevant. Find the probability of defective is required. Not defective is not required. So I have not written. Probability of machine 3 is 0.1. What is the defective probability of defective when machine 3 is selected? So D by D when given M3 is 2%, 0.02, and 98% not defective when machine 3 is selected. This is not also required. So I am erasing this part. Now what is required? Find the probability of defective output when a product is selected at random. So what is the probability of defective? You see, a product would be taken at random, and what is the probability that it is defective? So it may be from machine 1 and it become defective. It may be machine 2 and become defective. It is machine 3 and become defective. So that means we want intersection of machine 1 and defective, machine 2 and defective, machine 3 and defective. So it is probability of machine 1 and defective. If I multiply this, if I multiply probability of M1 into probability of defective when M1 taken, this is equal to probability of M1 and defective. You apply this, probability of A when B has occurred is equal to probability of A intersection B by probability of B given. So if I multiply this, so it will be probability of A intersection B. So here probability of M into D defective given M1, if I multiply these two, we will get probability of M1 intersection defective, M1 intersection defective. That means machine 1 is selected and defective occurred both. So if we multiply, we will get intersection of machine 1 and defective. So if I multiply these two, we will get probability of M1 D1. So this is equal to probability of M1 intersection probability of M1 into probability of D when M1 occurred plus probability of M2 into probability of D when M2 has occurred plus, this is not part of this calculation, plus probability of M3, probability of defective when M3 has occurred. So if I multiply these two, that is 3.6 into 0.1 plus 0.3 into 0.05 plus 0.1 into 0.02. So result is, you may calculate 0.077. 0.077 is the probability that selected item is defective. So before going into details of Bayes' theorem, you must know what is total probability. I repeat, you make this chart for calculating probability as per Bayes' theorem or total probability, and you see the probability of these three add, you will get 1. And now if this is selected, given this, what is the probability of defective event, what is the probability of this event, given that M1 is this, and corresponding probability of M3 is this, and probability of defective when M3 is occurred, it is given in the problem 5%, probability of M3 is 0.1, and if M3 occurred, what is the probability of defective is 0.02, 2% means 0.02. And if I multiply this and this, we will get intersection of machine 1 and defective. If I multiply this into this, we will get intersection of machine 2 and defective, because you see the conditional probability A intersection B is equal to probability of B into probability of A given B. Same thing. Here if you multiply this and this, you will get probability of M1 and defective. Clear? Similar, if you multiply this into this, you multiply this into this. Same thing, and then you will get probability of defective. So clear? So we have understood how the total probability of defective is calculated. It may be from machine 1 and become defective, machine 2 and become defective, machine 3 and become defective. So this into this intersection this into this intersection of M2 and defective, this into this intersection of M3 and defective. The probability of defective, this into this plus this into this plus this into this. So you will find the total probability of defective. Clear? Clear or not? I think it is clear. Now I will come Bayes' theorem. What type of question is asked in Bayes' theorem? Now same problem. What is required as per Bayes' theorem? Same problem, but this time what is asked? An item is found to be defective. An item when selected found to be defective. What is the probability that it is from machine 3? A defective item is found. So I have calculated the probability of defective. This into this plus this into this plus this into this is equal to 0.007. An item was found to be defective. What is the probability that it is taken from machine 3? Or question may ask what is the probability that it is taken from machine 2? If it is defective, what is the probability that it is taken from machine 1? So this time it is asked an item when selected found to be defective. What is the probability that it is from machine 3? That means it is backward. What is required? Probability, conditional probability. What is the probability that it is from machine 3? M3. Given that the item was found defective. This is required. What is the probability of it is taken from machine 3 given that the item found defective? So this. So you know conditional probability of A when B has occurred, intersection probability of A, intersection B and probability of B. The given is taken as denominator. So here what would be its formula? Probability of M3 intersection D as per conditional probability divided by probability of D given the defective occurred. That means what is the intersection of this? How will calculate? This into this. That means we require the multiplication of these branch. If I multiply probability of M3 into dM3, it will become, the product will be this into this. It will be probability of M3 and defective. Intersection of M3 and defective. That means in the numerator you will put product of these two probability. So this would be equal to 0.1 into 0.02 and denominator is probability of D. Probability of D means 0.6 this 0.6 into 0.1 plus 0.3 into 0.05 plus 0.1 into 0.02 equal to 0.002 by 0.002 by 0.077. So answer is 2 by 77. This is the answer. I repeat, this is according to the Bayes' theorem. You must write according to Bayes' theorem. According to BAYES apostrophe. According to Bayes' theorem. According to Bayes' theorem, probability of M3 given this into intersection of probability this into this, and since D is occurred, defective occurred, probability of defective. That means this into this plus this equal to this, just into this. That is, in the numerator we will get this into this, numerator this branch, this into this, and denominator this into this plus this into this plus this into this. So this is according to the Bayes' theorem, the probability of selecting machine 3 when item is found to be defective. This is not a bit hard, but unless you know the total probability, it is very difficult. Now, according to Bayes' theorem, the probability of, suppose there are events A and B, the probability of B1, B2, B3, total 1. There are 3 events, B1, B2, B3, and probability of A, like defective when B1 is occurred, probability of A when B2 has occurred, probability of A when B3 has occurred, given. So now it is according to the Bayes' theorem, it is asked probability that what is the defective has occurred or event A has occurred. What is the probability of B1? That means B1 or BI, I have in general written BI. What is the probability of B1 when A has occurred? That means intersection, probability of intersection BI and A. And denominator, event A has occurred, that means probability of B1 into probability of A when B1 occurred plus probability of B2 into probability of A when B2 has occurred plus probability of B3, probability of A when B3 has occurred, or we can write probability of BI intersection A, and you can write sigma probability of BI into probability of A when BI occurred, sigma, and I from 1 to n. So this is the formula according to the Bayes' theorem. If you do not understand, you have to memorize. So what you will do? You see, just it is asked probability of BI when A has occurred. You just flip this one. So if I flip it, I will get probability of A by BI, it may be 1, 2, 3, and multiply it by probability of B. What you see in the denominator, multiplied by probability of I divided by probability of A. Probability of A means this into this plus this into this probability of A. Clear? You see, same formula. If you get this, you may write this one. You see, it to some extent different. So this equal to, you may write this equal to probability of BI into probability of A when BI has occurred. So ultimately this equal to this divided by sigma P BI probability of A BI I 1 to n. That is, you can assume this is equal to probability of A. So I am repeating again. First of all, probability of B, I and occurred. What is the probability of B1 backward when A has already occurred? So given A has occurred, so we will take that branch. If B1 is required, we will take this branch. If B2 is required, this branch. Other BI into ABI, BI into ABI. This formula would be applied, and in the denominator this into this, this into this, this into this. That is sigma BI into ABI. Sigma, that is probability of A. Or if you cannot understand, you memorize this. What is required? Probability of, suppose it is required probability of B1. So probability of B1 by A, you just flipped A by B1 and you have written here B1, so multiplied by P B1, and then in the denominator probability of A. That means this into this into this plus this into this. Clear? What is required? If it is required, what is probability from machine 2? If it is A has occurred, what is the probability that it is B2 occurred? Take this branch, and in the denominator this into this, this into this, this into this. In the denominator always you will multiply and add, and in the numerator you see which is the branch is required. Take the branch as numerator, that branch as numerator, then you will get this probability. This is according to the Bayes theorem. Second problem, very good problem for understanding. A person got a contract job. A person got a contract. The probability of strike, the strike, employee strike, is 60%. And what is the probability that there will be no strike? Obviously 40%. Total must be 1. That the probability that the job is completed in time in case of strike is 30%. Since there is strike, there is no, sometimes may not be job, may not be completed in time. The probability that the job is completed in time is 30% if there is strike, and the same probability of completion job in time when there is no strike is 80%. If there is no strike, the probability that job will be completed in time is 80%. Now what Bayes theorem say? Given that the job was completed in time, what is the probability that there was strike? So according to Bayes theorem, you have to calculate. According to Bayes theorem, B-A-Y-E-S apostrophe theorem. So let us take two events. Event A, the event of occurrence of strike, and event B, the job is completed in time. So what is the probability of that there is event A occurred? Strike will happen. Probability of A is 0.6, 60%. And what is the probability that there is no strike? That means I may take A complement. Probability of A complement is 0.4 and total is C 1, 0.4, 0.6. You should check it. This would be 1 sum. And now says the probability that the job is completed in time in case of strike is 30%. In case of strike means this one, there is strike. In case of strike, the possibility the job could be completed in time, hence means probability of B when A has occurred, when strike occurred, is equal to 0.30%, that means 0.3. And the probability of job completion in time, the same when there is no strike, is 80%. No strike, that means A complement is equal to 0.80. Now what is required? According to the Bayes theorem, given that completed, what is the given? Given is B. What is the job is completed in time? What is the probability that there was strike? Strike means A. So according to the Bayes theorem, probability of A when B has occurred, that means job was completed in time. This is required. So how will calculate? First, this means probability of A intersection B divided by probability of B. So total probability of B. and this is equal to which branch is required? This branch. That job was completed in time, and what is the probability that there was strike? That means you have to take this branch. So what is the product of this one? Probability of A into probability B intersection A is equal to probability of A intersection B. Isn't so? Probability of this is equal to probability of A into probability of B when A has occurred. You know, probability of this into this means probability of A intersection B. So A intersection B is probability, product of these two. Probability of A into probability of B when A has occurred. So it will be probability of A intersection B. A intersection B. And here probability of B. Now how will you calculate? Very easy. What is required? Probability that there is strike, given that job was completed in time. That means numerator will be this into this. So 0.6 into 0.3 divided by total probability of B. Means there is job was completed in time. If there is strike, job was completed in time. If there is no strike, job was completed in time. That means this into this plus this into this will give the probability that the job is completed in time. That means job is completed, there was strike and job was completed in time. This into this intersection plus there was no strike and job was completed in time. That means this into this. So total probability that the job was completed in time is this into this plus this into this. That means 0.6 into 0.3 plus 0.4 into 0.8. So equal to 0.18. 0.18 divided by 0.30. 0.18 divided by 0.18 divided by 0.18 plus 0.32 equal to 0.18 by 0.550. That means 18 by 25. That means 9 by 25. 9 by 25 answer. The answer is 9 by 25. This is our answer. Clear? What is required according to the base pen? You see the first and take numerator required branch and denominator this into this, this into this. This will give the probability of B. Or those who want to memorize, first required is A by B1. First flip this B by A, and multiply it with probability of A. What is it? The numerator you see A, so multiplied by probability of A. Now given B, take the probability of B. Probability of B means this into this plus this into this. This is according to the Bayes' theorem, probability of strike when job was completed in time. Clear? It is also a very good problem. Problem number 3. There are 3 bags. Bag 1, bag 2, bag 3. So in bag 1 there are 5 balls. In bag 1 there are 5 balls. 4 balls are white and 1 is black ball. In bag 2 there are total 6 black and 6 white balls. In bag 3 total ball is 4, out of 1 is white and 3 is black balls. So a bag is selected at random. Any bag is selected at random and ball is taken out and a ball is taken out observed to be white. A ball is taken out and it is found that the drawn ball is white. So it is a given condition. Given condition. The ball is taken to be white. So what is the probability that it is from bag number 1? So what is the probability that the ball was taken from the bag number, white ball was taken from the bag number 1. So let us make a chart. So first 3 bags, the probability I have taken A taking white ball event and B is the event of selecting bag. The probability of bag B1 selecting is, there are 3 bags and selected at random, that means its probability is 1/3. And selecting bag 2, probability of B2 is also 1/3 and probability of B3 is also 1/3. You add total 1. You note. And what is the probability of selecting a white ball? Because it is still that taken ball is observed to be white. So what is the probability that the taken ball is white? It may be from B1, it may be from B2 or it may be from B3, bag 3. So if it is from bag 1, what is the probability of white ball? That is probability of A when B1 occurred. A when B1 occurred. A1 is white ball. So when B1 occurred, what is the probability of white ball? Total 1, 2, 3, 4, 5. So white ball is 4/5. And next, the probability if white ball when bag 2 is selected, so out of total ball is 12, 6 are white. So probability of white ball when B2 was selected is equal to 6/12, that is half. And here when third bag is selected, probability of white ball A when B3 occurred equal to 1/4. Clear? We are interested in white ball, not black ball, because the observed ball is white. It is given condition. So according to the Bayes theorem, you must write it, Bayes theorem. What is required? What is the probability that it is from bag 1? That means B1. Probability of B1 when A has occurred, white ball occurred. Which branch required? It was from bag 1. That means numerator this branch, this into this, and denominator this into this, this into this, this into this, this into this plus this into this plus this into this. So this will be probability of plus, you may flip it. So probability of A when B1 occurred to probability of B1, and now probability of A. So this branch probability of B1 into AB1, 1/3 into 4/5. 1/3 into 4/5 and numerator 1/3 into 4/5 plus 1/3 into half plus 1/3 into 1/4. 1/3 into 4/5 divided by 1/3 into 4/5 plus 1/3 into half plus 1/3 into 1/4. This is equal to, you will solve. I am giving you the result. 4, 5. Will be 4/15 divided by 31/60 equal to 16/31. 16/31 answer. Answer 16/31. This is the answer. 16/31. 4/15 into 16/31. 16 by 31 is the answer. That is what is the probability of selecting bag 1 when drawn ball came to be white is 16 by 31. This is not very difficult. What is required? Take that branch as numerator and divide it by this into this plus this into this into this into this. This is a simple. First you can flip it and see the denominator probability multiplied by probability of B and now probability of A because it is given. Number 4 problem of part 1 video on Bayes' theorem. Given that there are 3 identical boxes 1, 2, 3. There are 3 boxes 1, 2, 3. So box 1 contains 2 gold coin. Box 2 contains 2 silver coin. This is NCERT problem. Box 3 contains 1 gold and 1 silver coin. A person select a box at random. So out of 3 boxes, 1 box is taken as random and a coin is taken. Takes out a coin. If the coin is gold, what is the probability that the other coin? So what does it indicate? Other coin is also gold. So first coin taken as gold, but what is the probability that other coin is also gold? That means their question is asking what is the probability that the box 1 is selected, because first one taken is gold and another remaining in the box is also gold. So what is the probability? That means indirectly they are asking what is the probability that the second box 1 is selected. The coin turned to be gold and what is the probability that it was taken for box 1. So what is the probability of selecting box 1, box 2, 3? Equal probability because the boxes are identical. 1/3, 1/3, 1/3, total is 1. And now what is the probability? What is the probability that the drawn coin is gold? If box 1 is selected, it has 2 gold, and what is the probability of drawing a gold coin? 2 out of 2, so 2 by 2. The probability of gold is G. G is the event of drawing gold coin. Gold coin is gold, and B is the drawing a box. So what is B1, B2, B3, 1/3, 1/3, 1/3? What is the probability of that the coin is gold, G, given that box 1 was selected? So box 1 is 2 gold, so out of 2 gold, 2, that means probability of drawing gold coin is 1. Then probability of drawing a gold coin in box 2 is selected, silver. So what is the probability of drawing gold coin? 0 by 2, 0 by 2, that means 0, because there is no gold coin, all are silver coins. So box 3, what is the probability of drawing a gold coin? Half, 2, 1 by 2. 1 is gold, total number of coin is 2. So this is the chart, and according, I am erasing this portion. According to Bayes' theorem, probability of drawing second box 1, first box. So probability of say B1, given that it was G, gold coin. So I have told you, memorize, you reverse it, probability of G by probability G given given B1 into probability of B1 by probability of G. So which branch required? First box, that means this branch. If you multiply this into this, 1/3 into 1 divided by 1/3 into 1 plus 1/3 into 0 plus 1/3 into half. So result is you can calculate 1/3 divided by 1/3 divided by 3/6. That means 1/3 into 6/3 equal to 2. That means 2/3 is the answer. Clear? According to the Bayes' theorem, as numerator we will take Dirichlet's branch because box 1 is required, probability of box 1, because second gold is only remain in box 1. The probability of box 1, this branch would be as numerator, and this into this, this into this, this into as numerator. This is the probability of drawing a gold coin. Clear? So I conclude part 1 video on Bayes' theorem. In part 2 we will take some good examples on Bayes' theorem. So you must view first conditional probability, then the Bayes' theorem, and the Bayes' theorem part 1 and part 2. So if you understand this topic, probability as per Bayes' theorem, so you like the video, you subscribe to my channel, share the video to your friends, relatives, so that they can understand, and my objective of making the video will be fulfilled. So you must watch part 2 video on Bayes' theorem. Thank you for watching my video.